systems of equations with graphing. We're going to focus on graphing the system to find the point of intersection between the two linear equations. So our learning target is I can define systems of equations and solve a system by interpreting a graph. All right, so our question starts again just to remind us what are systems of equations. Systems of equations are two or more linear equations that share two variables. You already have that definition, but you can write it again. Remember, you can pause and rewind at any time to catch what you need to catch here. All right, so how do I solve a system of equations with a graph? Well, the key, as we talked about before with the systems of equations, is that we want our linear equations in a certain form, and that is slope-intercept form. Okay, because we can use the intercept to start our graph, and it'll start on the y-axis, and then we can use the slope to get more points on that line. So for our systems with the graphing, we want to make sure that both linear equations in the system are in slope-intercept form. And then we can build that graph and interpret that solution, what that means for that graph. All right, so the first one we're going to do is just a graph. There's no meaning behind the two equations that are part of the system. I have 4 steps laid out that we're going to follow. So identify form of the equations. All right, if we look at our two linear equations in the system, our first one is y equals negative 2x minus 3. And our second one is y equals 2x plus 5. So we know that they are both in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. And they both are y equals with a something x and your b, okay? So now that we know that they're in slope-intercept form, we're going to graph using the y-intercept and the slope. And we were practicing this a little bit before. All right, so in our first equation, we have y equals negative 2x minus 3. So our m, we find it is attached to the x, and that's a negative 2. So our slope is negative 2 over 1. So we're going to go down 2 and to the right 1 from the y-intercept. And the y-intercept is the next part of the equation. It's our b. Our b is a negative 3, but we write that as an ordered pair. 0, negative 3. It starts at 0 because we stay on the y-axis. We either go up or down. So if we graph that line in our system, we've got start at 0, negative 3. So I'm at my origin and I go down 3. That's on my y-axis because it's my y-intercept, right? And now I'm going to use my slope to find more points on the line. So from there, I go down 2 and to the right 1. And then from that point, down 2 and to the right 1. Okay? And then I would make my straight line, or as straight as I can, on this jam. Now, my second equation in my system is y equals 2x plus 5. I'm going to pull the same information out. I know my slope is attached to my x. That's a positive 2 over 1. So this time I will rise 2 and then go to the right 1. And my y-intercept is positive 5. And I write that as an ordered pair, 0, 5. All right, so go back to my graph. Start at 0. This time I'm going up 5. And I'm going to rise 2 and go to the right 1. Like that. And I'm going to draw my line. All right, so we identified the forms and we graphed using the slope and y-intercept. So now we're on step 3, which is to find the point of intersection. Where do they meet? Intersection. Right, and that looks to be right here. My red line isn't super straight, but the point of intersection I have circled in green, and I'm going to figure out that ordered pair by starting at my origin. I go left 2 on the x-axis and up 1. So the point of intersection is -2, 1. All right, now to prove that, I'm going to substitute that ordered pair, substitute my point of intersection into each equation and see if it makes a true statement, okay? So my first one is y equals -2x minus 3. All right, my y is 1, so I'm going to substitute 1 there. 1 equals -2 times x is also -2 minus 3. And then I have some PEMDAS work to do on the right side. This left side stays 1. -2 times -2 is +4. And then I have to do 4 minus 3. And 4 minus 3 is 1. So 1 equals 1. So it worked in the first linear equation in our system. Let's see if it works in the second one. We're going to substitute -2, 1 into y equals 2x plus 5. So again, y will be 1. I'm just taking the ordered pair and substituting in for x and y. And then 2 times -2 plus 5. Left side stays 1. 2 times -2 is -4 plus 5. And -4 plus 5 is 1. So it worked in the second linear equation in our system. So our point of intersection is -2, 1. And we can see that on the graph. We got that from building those lines. Now, let's look at a real world problem where you would need to then interpret what the point means for that situation. So we're going to jump down to actually just the second problem here. And we might come back in class time to do the first one. Same steps, or not same steps, actually, we have some different things going on here when we have a word problem. So we need to define the variables first. We need to write the system of equations, so we're not given the 2 linear equations. We're going to graph still using slope-intercept form. And then we're going to find that point of intersection. Okay, so we're going to go down to the second problem, creative crafts and scrapbooking. Creative Crafts gives scrapbooking lessons for $15 per hour plus $10 supply charge. The Scrap Shack gives lessons for $20 per hour. Graph the system of equations for the 2 places at the right, and then interpret the point of intersection. Okay, so we know a system has to have 2 variables, so we're just going to use x and y. And in this case, we're talking about 2 things. We're talking about number of hours and the cost. So we're going to make x be our number of hours that we spend crafting at the shack or the creative crafts. And then y will be your total cost. Okay, so now we're going to write 2 linear equations based off of what the information we know in the problem and using the variables x and y. So we're looking for the total cost if you decide to go do your scrapbooking at Creative Crafts. So we're going to start with y equals because we're calculating that total cost. Okay, at Creative Crafts, it's $15 per hour plus a $10 supply charge. So x is the number of hours. It's $15 per hour. So depending on how many hours you spend there, you're going to multiply that by 15. And then you're just charged $10, an additional $10 for the supplies that you might need. All right, at the Scrap Shack, to find the total cost, it says they give lessons for $20 per hour. And there is no supply charge. So however many hours you're at the Scrap Shack, you're going to multiply that by 20. All right, now we're going to pick out the information that we know about each of these things from our slope-intercept form, what we know about slope-intercept form. Okay, so in Creative Crafts, y equals 15x plus 10. Well, we know slope-intercept form is y equals mx plus b. So we can tell our slope in Creative Crafts is 15 over 1. And our y-intercept is a positive 10. Now the Scrap Shack, we know that our slope is 20 over 1. It's $20 per hour. And our y-intercept, we have nothing here being added or subtracted because there's no supply charge. There's nothing, and we represent that with the origin. That's at 0, 0. Okay. All right, so I have a graph here, and we're actually going to fill this in. On the y-axis is where we're going to put our total cost. And on our x-axis is where we're going to put the hours. Now we need to add some numbers to our graph. Of course, this is the origin in the corner here. And hours, we're just going to count by ones. So each grid line will be a 1. I'll go up to 10. Now total cost, it doesn't make sense to count by ones because they're charging, one place is charging $15 an hour, another is charging 20. So maybe let's go by tens. 10, 20, 30, 40, 50, 60, something like that. Okay? All right, now my Creative Crafts, I'm going to make that line red. So my y-intercept, my total cost starts at $10. So I'm going to put a dot here on the 10 because you get charged for supplies there, which makes sense. You got to build a scrapbook, you need supplies. Okay. And then it goes up 15 for every hour that you're there working. So from 10, if I add 15, that's 25. So I would be at between 20 and 30, and then write 1. 15 over 1. All right, and then 25 plus 15, that's going to be 40. So I go up to 40, and then write 1. And then 40 plus 15, I'd be at $55. So between the 50 and 60, and then write 1. That's pretty good. So I'll draw my line as straight as I can. Okay, and that's Creative Crafts. I'll put that in red. All right, now Scrap Shack we're going to do in green. There is no initial charge, so you start at the origin. And every hour you're there, it's $20. So I go up to 20 for 1 hour, over 1. If I'm there another hour, now it's 40 and on to 2. And look at that right there. You can see that's an overlapping point, right? Let me do 60 and 3 just so I have four points for this line too. But we can see that point of intersection. Whoop, my line got a little crazy there, sorry. We can see that point of intersection. I'm going to circle it in gold. It's right here at 240. Now, what does that point of intersection mean for this problem? What it means is the lessons would both cost $40 for 2 hours at either Creative Crafts or Scrap Shack. That's the point where both places cost the same amount of money. Okay. And then after that point, one of them gets more expensive than the other. And you can see that in the graph. So the point of intersection means the lessons both cost $40 for 2 hours. That's where they're the same. If you're going to go over 2 hours, then you would choose the cheaper of the two. All right, let's put this to practice. Bring your notes.